Hey everybody, welcome back. Let's take a look at number 119, Pascal's triangle 2. In this question, you're given an integer row index and you need to return the row indexed row of the Pascal's triangle. The rows here in the triangle it starts with a 0 based index. So the first row is 0 and the second row is index 1 and so on and so forth. So like in the case of an array. Let's take a closer look at the triangle. On the first row, we have 1. On the second row, we have 1 and it ends with a 1. And on the third row, it starts with a 1, middle value is 2, and it ends with a 1. So the first row here is special. It only has a single value and it's going to be 1. And for all the other rows that follow, you can see it always starts with a 1 and it always ends with a 1. And there's a way you can use that to your advantage when you're coding. Imagine the row index that you get for the input is 0. So the result of it is going to be an array with a single value of 1. Let's define that right now. So result is going to be an array of 1. And there's going to be some calculations going on here, but in the end, you can return the result. So this takes care of the case when row index is 0. Now, what about when row index is 1? You can get the next row by building upon the previous row. That means row 1 is going to be built upon row 0. In this case, row 0 is an array containing 1. Now, what should be the result when row index is 1? The result is an array containing 2 elements, 1 and 1. In order to reach that result, you can create a loop that will iterate until you get to the row that you want. And you need a second loop that will fill the current row with the proper values. Let's visualize that a bit better. So these are the row indices and its corresponding values. And again, the outer loop is going to take care of moving from one row to the other. And the inner loop is going to take care of filling up the rows with the correct values. So going back to the code, let's start off with the outer loop. Let I equals to, we say starting at 1. Because we already have the result for row index 0. And then we say I less than or equals to row index because we want to work on the current row, which is 1, and I++. For the inner for loop, in order to construct the values in the row, what you can do is start from the end of the row and make your way backwards. This is because you know the last item in the row has to be a 1. But how do you know if the value you're currently adding to the row is the last item in the row? Let's take a look at that. When the row index is 1, the last item in that row is also at index 1. When the row index is 2, the last item is also at index 2. 0, 1, and 2. So if we're representing the value that's been added to the row currently using the letter J, we can say whenever I is equals to J, then we're adding the last item into that row. So we can directly insert 1. So for the inner loop, we start with J equals to I, and then we say J greater than 0 because we already have the first element in the array, and then J minus minus. And inside there, if we know J is equals to I, then that means we're adding the last item into the result array, and that is going to be a 1. So result of J is going to be 1. Next, let's take a look at how to generate a row when the index is 2. So in the case of 2, with the code that we have so far, on the first iteration, we have the result value as an array containing only 1. And on the second iteration, we're going to have an array containing 1 and 1. And on the third iteration, when it works on row number 2, we'll have an array that contains 1, 1, and 1 initially. And this is when J is equals to I, 2 is equals to 2. Now the inner loop is going to continue until it reaches a value greater than 0. And that's how we're going to get the correct values for the row. Because as you can see, the middle value here so far isn't right. So on the next iteration, when J becomes 1, it's going to fix the value at index 1. And you can fix that as, imagine the result array is called R. So then R of J is going to be equal to R of J plus R of J minus 1. So J being 1 here, the new value at index 1 is going to be this plus value before it. So this is going to turn into 2. So with that, we can write in the final piece of the code saying result of J is going to be result of j plus result of j minus 1. And that should be it. Thanks for watching. Let me know if you liked it, and I will see you next time.